Hello. In this Coolgrad video, we are going to talk about QA best practices specific to testing. We're going to talk about how to write efficient test cases, the different types of test cases, and how to execute test cases. I have another video on QA defect management, which is separate from testing and test cases. So this video is going to talk about specifically testing and test cases. So in this video, we're going to talk about what is quality assurance versus quality control, different types of testing, positive, negative, UI, regression, and performance testing, manual versus automated testing, what are the differences and details about that, various testing phases, introduction to different tools used in testing, how to author efficient test cases. We're going to actually write some test cases hands-on, using some examples, and how to execute test cases using tools like Rallye or HP, ALM, or Quality Center. So what is QA and QC? QA is quality assurance and QC is quality control. Quality assurance is the process or set of processes used to measure and assure the quality of a product. QA is all about, are we building the product right? So the customer has given us a bunch of specifications, they tell you what kind of product they want, and we are building the product. QA is all about, are we building the product right? And what is quality control? Quality control is the process of meeting products and services to consumer expectations. Quality control is about, are we building the right product? So verification and validation are performed to ensure that quality standards and objectives are met. So I think this is kind of self-explanatory. So are we building the product right? So the testers are just going to execute test cases to see, is this according to specifications or is there a defect? But they're not really going to worry about, are these the right test cases in the first place? That's more like a business analyst kind of role. It's a much higher level of detail and introspection and quality control, where we talk about, are we even building the right product? Is this really what the consumer wants? So these are two different aspects of quality. Verification versus validation. So in verification, we look at the software development life cycle and evaluate the intermediary work products in the SDLC to check if we are in the right task, we are in the right track of creating the product. So validation is the process of evaluating the final product to check whether the software meets the business needs. So verification is, are we building the product right? Validation is, are we building the right product? So let's talk about the different types of test cases. So test cases may be user interface, positive, negative, regression, or performance test cases. So that includes load and stress testing. So we're going to talk in detail about each of these types of test cases. What are UI test cases? User interface test cases are used to test if all the UI elements on a page, like the buttons, text, font, labels, checkboxes, borders, display, colors, scroll bars, etc. are correctly displayed and aligned in various browsers, operating systems, etc. So we have to make sure the software works correctly in all different browsers and operating systems. We have to make sure all the UI elements of a page are aligned and displayed correctly, that they have the right size, color, alignment, and type. So this is all about UI testing. Positive testing is done by providing correct inputs and make sure the system gives you the correct output. So this is also called happy path testing. Negative testing is done by providing various types of incorrect data to the system, boundary conditions, special characters, etc., and try to crash the system in every possible way and make sure that the system gives you the correct error message in every scenario and the system always exits gracefully in every situation, that it doesn't crash under any situation. Regression testing. Regression testing is done to ensure that in the process of building new functionality, we didn't break previously working functionality. So if there was something we built earlier and it was working fine, in the process of adding new functionality, we have to make sure we didn't break that stuff that was working previously. So we usually re-execute the test cases related to the original functionality and make sure it's working fine. Manual versus automated testing. So in manual testing, the testers capture test cases step by step. And every test case is of the format of an input and an expected result. In every test step, we make sure there's an expected result and the system gives you the expected result. So they capture the test cases in tools like Rallye, Jira, TFS, that is Team Foundation Server, or HP ALM, that's Application Lifecycle Management, or HP Quality Center. So these are different tools where people can write test cases. Automated testing is done after the system is fairly stable using automated testing tools like QTP, that's Quick Test Pro. So manual testing, they execute test cases step by step and check out the results and log defects. In automated testing, they train the automated software to execute test cases by training it to record the steps and then execute the steps. The software can execute the steps multiple times again and again. So in some situations where you have so much testing to do that manual testers, it's practically impossible for them to do it, we use automated software to execute the test cases again and again and again. And sometimes where elaborate real-time testing is required, we use automated testing tools. So performance testing is used to measure the response time of the application and is usually automated using tools like load runner. Performance testing is also called load or stress testing. So when there's a web application and the server and there's going to be like tons of people, thousands or millions of users hitting the website in a very short span of time, we have to make sure the web server is able to withstand the load and respond in real time. And this is done using tools like load runner. So if you can't simulate like 1 million users to hit a website at the same time, we can use tools like load runner which create virtual users which hit the website at the same time and they measure the performance of the website. Performance testing. So it's a process of making sure the web server can withstand stress and the number of hits. So in performance testing, we have a large number of users hitting the website at the same time, and it generates a lot of reports automatically which tell us how the application is performing, how much time does it take to respond, and which page is loading, which page is not loading. And it gives various performance metrics. So there's a tool called load runner which has a virtual user generator, and the VUGen simulates hundreds of thousands of virtual users that hit the application at the same time. It's very difficult to do this using manual users, and depending on what license you have a certain number of users that can hit the website simultaneously, and then we measure the performance of the application. This is very important if you are in India, like earlier in nowadays, in the engineering colleges, when the results of every semester were announced, the website would be so slow and sometimes it would crash because it wasn't obviously designed to withstand the load. All the students would log in at the same time. So sometimes we need to have distributed servers. Like Google, for example, has more than 1 million servers across the world in all different cities so that people get response in real time. What is a test plan? A test plan is a high-level document prepared by the QA manager or the QA lead to propose the scope, the timeline, the resources, and various phases of the testing process to ensure that QA objectives are met. So, test plan also contains details such as various testing phases. So, it details from this date to this date, 2 months we're going to do end-to-end system testing. Then we're going to do system integration testing. And then we're going to do UAT. So it details all the different test phases. And it talks about the deliverables in each phase, who participates in each test phase, details of how UAT is conducted. So where it's going to be conducted, which UAT testers are going to be involved, which business team members are going to be involved, what are the metrics, so how many P1, P2 bugs can we have open, and when are we going to sign off on the UAT. All these details, which resources are going to be deployed, all these details will be mentioned. How to write efficient test cases. So we're going to talk about the format of a test case, the title of the test cases, the categorization of test cases, capture multi-step test cases, how to write comprehensive test cases, and the sequence of organization of test cases. So which one comes first, which one comes next. Write comprehensive test cases. So in a lot of organization, you might have seen users writing very small test cases, like 5 steps, 10 steps each. So I recommend writing test cases of at least 30 to 40 steps, comprehensive end-to-end test cases, even in the early testing phase. The advantage of writing comprehensive test cases is that these can be potentially reused for UAT. So in the UAT, there's comprehensive end-to-end testing. So even if you've written very small test cases, they have to consolidate all of them or write new test cases from scratch for the UAT. But if you have slightly comprehensive test cases written right at the beginning, at the epic story level or the feature level, then these can be reused for the UAT. And also, writing comprehensive test cases eliminates a lot of redundancy. So if, for example, in every test case, whether it's 5 steps or 3 steps or 10 steps, it starts with this input, log into home page. And it says, the expected result is home page is displayed. So that's usually the first step in almost every test case. So it's like a waste of time, right? If you consolidate them, there's a smooth flow which goes from one process to another, and end-to-end testing is done. So it's always good to write comprehensive, smooth flowing test cases. So identify like a test scenario by clubbing in a few user stories and write them at the epic story level. So the test case spans across multiple user stories across which all belong to a particular epic story. So that's it's good to write comprehensive test cases, about 30 to 50 steps each. So write multi-step test cases. So in tools like Rallye or ALM or Jira, there's the multiple test steps that you can create. So in every test step, you're supposed to write one input and expected result. So some people capture these test cases in Excel sheets, and then they try to upload them into Rallye. So what happens, I've seen previously, is that all these test steps are put into one single test step in Rallye, and it becomes really difficult to read. So capture them directly into Rallye or Jira or TFS, writing step by step. That makes it easier for visibility. So this also helps in better readability and in metrics reporting. Suppose in a particular test case, out of 30 steps, suppose 3 steps failed. So you want to know how many test steps failed, right? So if all this data is sitting in one particular step, it's very hard to say how many test steps failed. So hierarchical structure. Write all the user stories in, maintain the artifacts in this particular hierarchical structure. Initiative, under that many features, under that many epic stories, under that individual user stories. Under that, each user story has test cases, defects, and tasks associated with it. So an epic story is nothing but a high-level user story which has multiple child stories under it. A feature has multiple epic stories under it. Like for example in Salesforce, the help desk module is a feature, the field service is a feature, and the training, contracts and entitlements is a feature. So these are all different features. So how many test cases to write per epic story? This is another common question that people come across. So one UI related test case per epic story usually. So we should first test all the UI elements of the pages corresponding to the epic story. So for any epic story, when we're writing test cases as a tester, first usually we capture the UI test case if the UI has been finalized. UI test cases must mandatorily have a screenshot of the UI attached for testers' reference once the UI is finalized. So usually we attach a screenshot in the UI test case. It's almost like mandatory for easy execution. And then we say, for every button, every label, every checkbox, every UI element, make sure it's correctly aligned, correct color, correct size, make sure it's correctly displayed. 3 to 4 positive test cases per epic story. So for every epic story, write 3 to 4 positive test cases, each about 30 to 40 steps. So identify scenarios. It depends on the size of the epic story. Some are really large epic stories, some are medium-sized epic stories, some are small epic stories. For a medium-sized epic story, I'm just saying, 3 to 4 comprehensive scenarios and write comprehensive positive test cases. So you give the positive input and expect positive output. 3 to 4 negative test cases. After UI and positive testing, we do a lot of negative testing. So we write 3 or 4 or even more comprehensive negative test cases, each about 30 to 40 steps long. So we provide various types of negative inputs and check the boundary conditions. And we make sure the system exists gracefully in every situation, that it doesn't throw error messages, it doesn't crash. 2 or 3 regression test cases. Identify the stories where the functionality could have been affected due to the development of this epic story, and write 2 or 3 regression test cases. So sometimes we write new regression test cases, or sometimes we just re-execute the test cases for that previous story. How to plan the testing effort. The testing team must create placeholders in Rallye for test cases, so identifying comprehensive test scenarios for the description section of these test cases. So for every test epic story, so first we create placeholders, test cases. We create some test cases and put in the titles and just leave them there. We plan what test cases must be written and what scenario it covers. And then testers must have a discussion with the corresponding product owners, business analysts, technical architects to discuss what they plan to capture in these test cases. And when they say, you make sure you include this, make sure you include that, and then they write all these steps in the test cases. Technical architect might have inputs about code-specific and system-specific testing. So they provide their inputs, which you can incorporate while writing test cases. And a lot of planning and structured effort must happen before you just start writing test cases. It's not like a tester just goes there, a junior resource, and starts writing test cases. Usually a QA manager or a QA lead must create hierarchical structure and create placeholders for these test cases, identify the testing scenarios, and put in the titles and description, and then make the testers write the test steps. So what are the various testing phases? There is end-to-end system testing and system integration testing, user acceptance testing, and validation testing. Usually these are different types of testing phases. End-to-end system testing is a type of functional testing, which tests all the functionality within a particular system. In one project we may have multiple systems. There may be Salesforce for CRM. There may be SAP's SD module for sales and distribution. SAP financials for financial module, and for time cards we may be using Lotus Notes. For something else we may be using Big Machines. So something else we may be using Aptus. There's all these different systems. And testing all the functionality within Salesforce, that's like end-to-end system testing. Or testing everything that happens within SAP payroll system, that's one particular end-to-end system testing phase. But when you're sending data across systems, you use an interface, like from Salesforce to SAP SD module, and from Salesforce to Big Machines. We use these interfaces, which are pipelines, like we send data across and get data back. These are interfaces. We call it system integration testing. UAT is end-to-end testing across all the systems in the project, which is done by the product owners or specific UAT testers. Validation testing is done by the compliance team for compliance reasons. And so this is for usually like FDA compliance, ISO compliance, and that kind of stuff. It's for auditing purpose. So end-to-end system testing, it includes all types of functional testing within a particular system. Positive, negative, UI, regression testing. And system integration testing is between all these various systems. For example, Boomi is an interface, and it passes data between systems. And UAT, usually end-to-end UAT test cases are written from scratch or by consolidating end-to-end system test cases. So if you write comprehensive test cases beforehand, we can reuse them for UAT. Validation testing is done mainly for auditing and compliance. So I'm going to talk about the format, generic format for is end-to-end system test case. So we say ST in the title to indicate system test, underscore US story number In the title, we put in the user story number. If it's tied to an individual user story, we put in the individual story number. Or if it's tied to an epic story, we put the epic story number. Or sometimes if it's spanning across 2 or 3 user stories, we put in all those user story numbers there. And we say category. So in the title, we can say it's UI or positive, negative, or regression. So that makes it easy. So you don't have to open the test case and look at what type of test case it is. So in the title, we usually say like positive or negative or UI or something else. And then we put in a high-level description of the scenario being tested. So for example, we shouldn't be describing the story here, but the scenario that we are testing. If you're testing like a help desk module, we are testing if you can create a case. So case creation is what we are testing. So we put in there. Integration test cases. So in the title, we say SIT for system integration testing. And then we put the story number. Then we put the category, which is positive, negative, or regression. Interface, there is no UI usually. And then we put the interface name. So sometimes there may be 30 to 40 interfaces in a project, a complex project. So we put the name of the interface. And then high-level description of the scenario being tested. For example, we're going to test if like a sales order comes in through Salesforce, and we're going to send that data to the SAP financial system and then get the data back or something like that. So what exactly are we testing? We put that description in the title. For UAT, so in the title we say UAT underscore user story number, whichever epic story or user story it's tied to. And the category we say UI positive or negative. Usually we don't do regression testing in UAT usually, so it's usually UI positive or negative. And then we put a high-level description of the scenario being tested. Organizing test cases in order. So we should organize the test cases one after the other, in a smooth order, so that it's easy for the testers to execute, so they're not like jumping all over the place. So first they execute the UI test case, and then the positive test cases, and then the negative test cases, and then the regression test cases. And in the SIT phase, system integration testing phase, they usually execute the positive, negative, and then regression. And in the UAT phase, they execute the UI, positive, and then negative. So organize the test cases per process flow. So whatever is the business process, according to that, organize the test cases so that they execute it according to the process flow. So we're going to talk about a sample positive test case. So this is an actual test case. So in any project anywhere in the world, if you're asked to write a test case, it's always in the same format. There's all these test steps, 1, 2, 3, 4, and each step has an input and an expected result. For example, this is a simple positive test case to make sure the login is working fine. So, for example, we go to www.facebook.com. That's the input. What is the expected result? System displays www.facebook.com homepage. That's the expected result. Input, enter the correct username. For example, abcd@gmail.com. Usually we give an example for the tester to, test. Remember, even if you're writing a test case, it might be executed by somebody else. So, put examples of what data to use. Enter the correct username. And what is the expected result? The system allows you to enter the correct username in the username field. Enter the correct password for this username in the password text box. So suppose password 123 is the password, so put that in here. So enter the correct password in the password field. What is the expected result? System allows you to enter the correct password. Then hit the login button. System validates the credentials entered, and if they are found correct, redirects you to my profile page. So if your credentials are correct and this is valid, so the expected result is when you hit the login button, system should take you to the my profile page. So this is an example of a simple positive test case. Give the positive username, positive password, and expect the positive result. Sample negative test case. So negative test cases, you have to make sure you cover every possible scenario in which you can break the system. So input, go to www.facebook.com. Expected result, it displays facebook.com homepage. Enter an incorrect username. So there are, for example, 3 different scenarios you can test. One is you enter incorrect username and correct password. Another is you enter correct username and incorrect password. And the third scenario is you enter a wrong username and a wrong password. So 3 different scenarios, and in every scenario it should display the correct error message and exit gracefully. So enter an incorrect username, for example abcd@gmail. So the .com part is missing, so that's an incorrect username. And system allows you to enter the username. It doesn't do any validation at that stage. And then enter the correct password. Suppose the password is pass123. System allows you to enter it. It doesn't do any validation. Hit the login button. So at this point the system validates the credentials, and as the username is incorrect, it displays the error message, incorrect username or password, in red color at the top of the username field. So whoever is testing, they should see where the error message is displayed, in which color, on top of the username field, what is the error message, so that should be displayed. Enter the same incorrect username as in step 2. So enter abcd@gmail, and system allows you to enter the incorrect username, and then enter the incorrect password, say 123. System allows you to enter it, and then hit the login button. So it validates the credentials and displays the appropriate error message, in which color, where. So next is enter the correct username and then incorrect password, and then hit the login button. Again, whatever error message is supposed to be displayed must be this thing. So we tested 3 different negative scenarios in this test case. So this is an example of a comprehensive negative test case. There's also so many other things we would test in a simple login module. Like for example, the boundary condition. You try entering more than 50 characters in the username or password field, and it shouldn't let you enter more than 50 characters, for example, or whatever the limit is. If it's allowing you to enter more characters than the limit, then that's an error. You try and enter more than 50 characters, it should not allow you to enter. So that's testing a boundary condition. Sometimes you enter special characters in the username field, like apostrophe or semicolon or something, which you're not allowed to enter. So that it should validate that as well. That's another type of negative testing. So this is one sample negative test case. So executing test cases in a tool. So we use create tools like HP Quality Center or ALM, Application Lifecycle Management, and to execute test cases, run test cases step by step. So when you say run, each test case is executed step by step. So every test step you can say pass or fail, pass or fail. If it's pass, you put a green tick mark. I mean the system displays a tick mark. And if it's fail, it's usually a red color X mark. Each test case is executed. If the test step fails, log a defect against that step. If all the test steps of the test cases have passed, then the system automatically marks the test case passed. So if every test step passes, then the whole test case passes. Even if one test step fails, then the entire test case fails. And the system will automatically mark the result of execution as fail. So a test case may have multiple defects that fail. So in one test case, multiple steps may fail. So for sometimes 3 test steps may fail. And for all those 3 test steps together, you might log 1 defect. Or sometimes for each of these, you might log a different defect. It depends on a case-by-case basis. So whenever a test case fails, you log at least 1 defect. So the developer has to go take a look and see how to fix it. So you can review my video about defect management to know how to log defects and get them fixed. So in Rallye, for example, if you're trying to execute a test case, you'll see here there's like 3 buttons. It's kind of small. If you press this button here, it will start executing the test case. You can execute it step by step, and then the next one has the picture of a bug. So that's where you log a bug. And the third one is to edit the test case. So it's actually very simple. Execute the test case step by step, mark the result of execution, and log a defect if required, and close the test case. So in Rallye, for example, there is one defect, like as of the year 2016, it doesn't allow you to execute test cases step by step. So you can't mark the result of execution step by step. Every test step you can't mark it pass or fail. So you execute all the test steps, and you can only mark the result of overall execution of the test case. So you have to add a custom field where you make a note of whichever particular test steps failed. Resolution categories for bugs. So when you find a defect or a bug, it may be resolved in multiple ways. It may be an architectural bug, which requires an architectural change to fix it. Code change. It might be fixed by a simple code change. Configuration change, by changing some elements on the page layout. And database change, some SQL query or database settings. Duplicate. It might be the duplicate of another already logged defect, so you don't have to fix this. Need more information. Sometimes you log a defect and the developer cannot fix it because he wants more information. Not a defect. Sometimes somebody logs a defect and it's not even a defect. They thought it was a defect, it wasn't even a defect. Defect resolution. They resolved it in some generic way. Software limitation. They thought it was a defect, but it was really a limitation of the software. User interface. It was a UI bug which they fixed by fixing the UI elements. Requirement gap. So there were some things which are not specified by the product owners and now they specified it. Data analysis. By giving the correct data, they fix the bug. Roles and profiles. So the user with no particular access to this functionality was trying to perform this operation and that's why he was not able to do it. So they use the correct roles and profile and they're able to do it. Change request. So this came through a change request and we have to fix the defect. Bug triage. A bug triage is a meeting usually like held for half an hour or 1 hour, sometimes on a daily basis, sometimes twice a week, sometimes thrice a week, where people, the entire team member, all the team members, the product owners, the scrum master, the QA leads and the developer leads and the technical architects, they're all present and they discuss and identify the root cause of all the bugs. And then they try to discuss how to fix these bugs and assign it to the concerned appropriate developer, and then they make sure all the bugs are resolved and closed on time. So the QA manager and scrum master drive the bug triage and induce a sense of urgency in the meeting, and they make sure the defects are resolved and identified correctly and fixed and closed on time. Overview of Web 3.0 guidelines, useful for user interface testing. Web 3.0 is the latest standard in guidelines to design web applications for easy user interaction on all web-based browsers, smartphones, tablets, and other mobile devices. So there's usually a set of guidelines about UI. You have to do things the way it's standardly done in many applications. You can't provide unpleasant surprises to users. Usually you expect like the login to be at the top right corner, and if you put your login button at the bottom left corner, they're going to be looking all over the place. It's not a pleasant user experience. So Web 2.0 guidelines was only for web-based interactions, but Web 3.0 is for all mobile devices and media. So for example, use at least a 12 size font and use a font like Arial. For example, the one in this PPT, in this PowerPoint is Arial, the one that doesn't have feet, so which is easy to read. Error messages are displayed usually in red. There was one time where we found a bug where error messages were being displayed in green, confusing the hell out of everyone. And warning messages must be in pink or orange. So if you display a warning message in red, then it scares the user. Oh my god, what did I do wrong? But it's only meant to be a warning message. Use different icons for different functionality. As a significant proportion of the population is colorblind, don't let the users rely on color code to identify UI elements. So if, for example, you use round buttons, one is green, one is orange, one is red, and each one does a different thing. Don't expect users to be able to distinguish colors. A significant percent of the population is colorblind. So use different icons instead. So cloud testing. So if you're using cloud-based software, testing a web-based application is relatively easier when it comes to testing cloud-based applications. So in this scenario, a lot of different companies, which are called clients, are all sharing resources on a cloud, like Salesforce. And we have to make sure that no particular client monopolizes resources, like the operating system or the storage. So coders must mass insert or update only up to 200 records at a time. If you try and update more than 200 records at a time, it should throw an error, because otherwise one company is going to monopolize all the resources. And this is called the governor limit. So Only 200 objects at a time must be inserted or updated or deleted, and that's called the governor limit. So if you're testing on a cloud-based platform, you must also test for governor limits. So this is done using scale test cases. It's written at a code level, and usually we write one scale test per object. So for example, in Salesforce, there's a sales cloud and a service cloud. In services, if you have 100 objects, we usually write one scale test per object. And during the system integration testing, only those objects which are touched by the interfaces will require, scale testing. This brings us to the end of this video on how to write test cases and testing best practices. I hope you find this useful, and in any software project anywhere in the world, these are the standard QA testing best practices. This is how you write test cases anywhere. You have test steps and then an input and an expected result. And when you're logging a defect, you write the actual result. So it's actually fairly simple if you think about it. I hope you find these guidelines useful.